The first principle of calculus is used to find the derivative of any function. The derivative of a function is a measure of how fast the function changes with respect to its input variable. The formula for the first principle is f(a) equals lim(to) 0 frac f a plus h minus f a h. To find the derivative of a function using the first principle, you need to find the values of the term for f x plus h and f x by identifying x and h. Simplify the expression under the limit and cancel common factors whenever possible, and evaluate the resulting expression's limit as h right pointing arrow 1. For example, let's find the derivative of f x equals x squared at x equals 2 using the first principle. 1. First, we identify x equals 2 and h as the small change in x. Then we find f x plus h and f x. f x plus h equals x plus h. 2 equals x2 plus 2xh plus h2. f x equals x2. 1. Next, we plug these values into the formula and simplify. f x equals lim(to) 0 frac f x plus h minus f x h. f2 equals lim(to) 0 frac 2 plus h 2 minus 2 2h. f2 equals lim(to) 0 frac 4 plus 4h plus h2 minus 4h. f2 equals lim(to) 0 frac 4h plus h2h. f2 equals lim(to) 0 4 plus h. 1. Finally, we evaluate the limit as h approaches 0. f2 equals 4 plus 0 equals 4. This means that the slope of the tangent line to the curve y equals x squared at x equals 2 is 4. Here are some more examples of finding derivatives using the first principle. 1. Find the derivative of f x equals x cubed at x equals 1. f x equals lim(to) 0 frac f x plus h minus f x h. f minus 1 equals lim(to) 0 frac minus 1 plus h 3 minus 1 3h. f minus 1 equals lim(to) 0 frac minus 1 minus 3h minus 3h2 minus h3 plus 1h. f minus 1 equals lim(to) 0 minus 3 minus 3h minus h2. f minus 1 equals minus 3 plus 0 equals minus 3. 1. Find the derivative of f x equals sin x at x equals pi 6. f x equals lim(to) 0 frac f x plus h minus f x h. f pi 6 equals lim(to) 0 frac sin pi 6 plus h minus sin pi 6 h. Using the trigonometric identity, sin a plus b equals sin a cos b plus cos a sin b. We get f pi 6 equals lim(to) 0 frac sin pi 6 cos h plus cos pi 6 sin h minus sin pi 6 h. Using the facts that sin pi 6 equals 1/2 cos pi 6 equals sqrt 3/2 cos 0 equals 1 sin 0 equals 0, we get f pi 6 equals lim(to) 0 frac 1/2 1 plus sqrt 3/2 sin h minus 1/2 h. Simplifying further, we get f pi 6 equals lim(to) 0 frac 1/2 plus sqrt 3/2 sin h minus 1/2 hc dot 1 per hour equals lim(to) 0 sqrt 3/2 1 per hour sin h. Using L'Hopital's rule 2, we get f pi 6 equals sqrt 3/2 lim(to) 0 1 per hour. Sin h equals sqrt 3 halves. Limto 0, 1, cos h equals sqrt 3 halves.